So we have 3 cups of waffle mix. So we're going to go ahead and write 3WM. That's the symbol that they gave us right here. So 3WM plus we have 2 eggs. So I'm going to say 2 EG plus 1 cup of milk. So we're going to go 1 MK yields or makes 12 waffles. So a batch of waffles with this recipe is 12. Okay? 12 waffles. All right. So we're going to kind of relate it to this little equation. This is just representing our recipe, but it all is coming from the recipe. Just remember that. All right. So when we're looking below, let's go right into number 1. It says, how many waffles can be made with 6 eggs? So a lot of us could approach this different ways. I'm just going to cross out the Gus part. We're not going to use that. That's given, unknown, and solving. I'm just going to kind of we'll just show our work. All right. So a lot of us have different ways that we would answer this question, right? So like you have unlimited waffle mix and milk and all that stuff, but you're like, oh, I have 6 eggs. How many can I make with those 6 eggs, right? So you have different ways to think of this. You could be like, okay, 2 versus 6. That is 2 times 3. So I could say 3, and then I could multiply the number of waffles times 3. And so you would figure out your answer that way. Anybody think that way? Maybe? No? All right. Other people, you might think of it more as like a proportion. And you don't realize you're thinking of it as a proportion, but you would say 2 eggs makes 12, which means 6 makes who knows. And then you learned this fancy little butterfly cross multiplying thing in math class. It's a proportion, right? Maybe cross multiplying. Okay. Anybody think of it this way? Maybe? No? Not yet? No? Still no? All right, that's good. So as long as they're empty brains, I'm going to fill them with stoichiometry then. All right. So what we're going to do is we're going to treat it kind of like how we've been doing these crazy problems, because you can always do it this way. So we're going to get into that habit again of underlining and circling. So we know that we're starting with 6 eggs. We got to get to waffles somehow. So I'm going to start by writing 6 egg like that. I'm going to say times in a line. Now, a little side note about this times in a line. I felt like a lot of people were getting very lost with railroad tracks, right? So if I had this and I was doing this and I colored that and I said EG down here and we went to waffles up here, okay? This is all that I'm doing right now, but I'm going to start using times in a line because I'm hoping that it's going to make it a little clearer on how to type into your calculator, all right? I'm not sure. But it's just the different ways brains work. It's okay. It's no bother to me. So we're gonna still bring a word down to the right. We're gonna put whatever we circled on the top. Okay. And so what we have here is we have 6 eggs, and then here we're like, okay, well, where am I gonna get this information? Well, looking at how we had set up a proportion earlier, we kind of used 2 and 12. Where do those come from? Up here in our balance equation, we have a 2 and a 12. Oh, they came from the recipe. Those were the original numbers, those coefficients, right? So we have 2 eggs makes 12 waffles. This is the relationship. That's the ratio. So if I have this, 6 eggs times 12 over 2, can you put that into your calculator and solve for it? Okay, then do it. Thank you. Okay, and if this is bothering you that there's nothing underneath this 6, it's all over the number 1, right? Kind of what's going on there. So you could even type it in that way. But you have 6 times 12 over 2. Yes. 36. Did you guys get that? 36? All right, good. So 36 waffles was your answer. Okay? All right. Next one, number 2, it says how many cups of waffle mix are needed to make 20 waffles? So I'm going to underline the number that we're given, and we're going to circle what we're solving for. We want to know stuff about waffle mix given how many waffles, right? Because we need to know how many of my ingredients do I need to make that many, right? So we're going to start with 20 waffles. I'm going to do times in a line. I'm going to still bring my word down to the right. By the way, why are we bringing the word down to the right again? Why did I do that over here? What happens when you have words on top of a fraction and on the bottom? They cancel out. Yeah, they eliminate each other. They turn into the number 1, right? So we want to cancel out words so that we're left with what we want on top. So we have waffles down here. We want to figure out waffle mix. So just like we did before, we got 12 and 2. What are we going to do for waffle mix and waffles? What number is going to go on top? A what? A 3. We're just pulling from our equation right here, that coefficient looking thing. And then down here for waffles, what number am I going to put? A 12. So we have 20 times 3 over 12. You can use parentheses in those calculators that you grabbed from the front table. That's why else I'm showing it like this, okay? But it is not changing. Okay, cool. So this is still, just so you know, 20, and then we had 3 over 12. So if you knew how to do it this way, please continue doing that, okay? 20 times 3 divided by 12. It's not going away. So you can always go back to railroad. All right, what did you guys get? 5? 5 cups of waffle mix. Perfect. All right, you guys are on a roll. So let's look at number 3. Number 3 says how much milk must be used with 5 eggs. So we're talking about 2 ingredients, right? So even though they're both on the same sides of the arrow, you can still use this method because we want to know what is that relationship, what is that ratio between them. So we're going to underline 5 eggs. We're going to circle the word milk because that's what we're solving for. So I'm going to start with my 5 egg times in a line. I'm going to bring the word egg down to the right to cancel that out. We're going to end with what we want on top, which is milk. Okay, what is the ratio here? What is milk to egg ratio? 1 and 2. Good. So now we have 5 times 1/2. 5 times 1 divided by 2. Yep. 2.5 is absolutely correct. So we have 2.5 cups of milk. Okay? Not too bad? All right. So now I'm going to put an image up here. And I want you to think about it. Because we're answering this next question, number 4. So number 4 says, okay, you have 18 cups of waffle mix, 9 eggs, and 5 cups of milk. What can you do with that, right? So I'm going to kind of take our brain away from the math way, right? I want you guys to look at the image. If you notice, I went ahead and put 18 cups of waffle mix. That's what the circles are. I have 9 eggs drawn. That's what the X's are. And I have 5 cups of milk, 5 squares. First thing I want us to think about. Why did I put these, my cups of waffle mix, in groups of 3? You could do that, but why specifically did I do that one in 3s and this one in 2s? Because we could do 9 in 3s as well. Yes. Yes, that's what we're going to get to. But what she said was that it's in the recipe, right? In the recipe, 3 cups of waffle mix. So I put them in groups of 3, right? I drew the 18, but I put them in groups of 3. I have 2 eggs for the recipe. So 1, 2, 3, 4, 5, 6. Oh, okay. I didn't hear that then. Sorry. 5, 6, 7, 8, 9. And then 1 cup of milk for each batch. Okay? So now that I've drawn this picture, you need to answer questions A and B. So you have 1 minute to discuss with your neighbor the answer to A and B. Okay? All right, you guys. So what we've got, okay, which ingredient out of this picture looks like it ran out first? Oh, that's not very confident, but yes, you guys are correct. Yes, eggs. Eggs. Because what you're seeing here is this is an entire batch. This is making our 12 waffles, right? So 3, 2, 1, 3, 2, 1, 3, 2, 1, 3, 2, 1. And then we go 3, 1, 1. Nope, that's not going to make the full batch. All right? So the one that caused that problem was the eggs. We were missing one, right? So eggs are something that ran out first in this recipe, okay, with that many ingredients. How many waffles can you make? So this one, I've seen a bunch of different approaches. So just kind of move us along. I'll just kind of tell you. You could have looked at this and said, oh, well, you could make 1, 2, 3, 4 full batches, so that's 48. So if you got to 48, you were almost there. You're almost there. But you didn't consider the fact that you could have made some with half the ingredients, right? So what we're going to do is we're going to look at this. We're going to say, okay, eggs are the only things that matter. Who cares if I had 18 cups and 5 cups? That didn't matter. What matters is that I had 9 eggs. This was our deciding factor. So we had 9 eggs times in a line. I brought eggs down to the right. I'm going to figure out how many waffles that makes. I know that every 2 eggs makes 12 waffles. So using that little ratio, you would have found out 54 waffles. Right? Anybody else get 54 eventually? No? Not so much? Oh, yeah. Yeah? Good. Cool. Awesome. All right. So all of that to basically bring up this next topic, which is what those eggs are. They are known as a limiting reactant. It's a reactant that runs out first and therefore limits the amount of product that can be made. Those 9 eggs stopped us from making 56 waffles, 55 waffles if that, right? It stopped the production of waffles, those eggs. Those other 2 things, the stuff that didn't run out, those things are known as excess reactants. Okay? These are just going to be reactants that remain after the reaction stops. So excess reactants are reactants that remain after the reaction stops because a reactant ran out. Okay? So this makes sense because you're like, yeah, okay, so if I don't have enough ingredients, I can't magically make these waffles. Side note, you can totally make waffles without eggs. I do it every weekend. But we're not going to talk about that. All right, so you can't magically make these waffles. So that should have made sense that that reactant, that ingredient was the deciding factor on how many you could make. One from a chemistry lab that you've had recently was the one where you had a strip of magnesium. You put it into the flame, and it lit, and it made this bright white light when you pulled it out of the flame. Do you guys remember that one? You weren't supposed to look at it, but everybody did. Right? The bright white light, yeah. Everybody was like, oh my gosh, my eyes. I'm like, you're happening too fast. I know it. All right, so that reaction right there was magnesium plus, we had a gas in this room. What gas was very, very prominent in this room? Oxygen, exactly. We were all breathing just fine. And it made ash at the end. So, between the magnesium strip and the oxygen in the room, which one of those decided that the reaction was done? So I've heard one of each. It's the magnesium. Because, what was our evidence that the oxygen didn't run out? We were still breathing, yeah. We were still breathing, right? So the magnesium strip, basically when it was done, it was no longer lit up, right? It turned into this ashy little pile that was left on the plate. Yeah, so the oxygen was the one that was in excess. This was your limiting reactant. So what I want you guys to be doing is in these labs that we're going to be seeing for the rest of the year, you're going to want to look for things that are limiting. What is the limiting reactant? What was the deciding factor about whether that reaction was going to keep going? Because once that limiting reactant runs out, it stops. Okay? And that's going to be where we base all of our calculations off. But don't worry about that yet. Today, we're more focused on just our process still. So, looking at number 7, it says determine the number of moles. So now we're turning on chemistry brains again. Determine the number of moles of iron produced from 12 moles of iron 3 oxide. So I'm going to go ahead and underline my number with the word attached to it. I'm going to circle what we're solving for. So if that's what we're given, 12 moles of iron 3 oxide, what are we solving for in this question? Moles of Fe. Good. So we're going to circle moles of Fe. Then you see that we have a balanced equation. So that's just like our little recipe that we had above. Okay. Same things there. We have coefficients. That's going to be what we're going to be using. Okay, so keep that in mind. All right, so when we go to set this up, we're going to start with 12 moles of this Fe2O3. I'm going to zoom in, that way people in the back can see this. All right, so Fe2O3, I'm going to do times in a line. I'm going to bring my words down to the right. So notice, I'm not just bringing down the units, I'm bringing down the units and a label. I need you all to get in the habit of that, and I will be checking your work today on that, okay? You need to be writing 2 things with every number from here on out. It's really annoying, I know, but you can get it. All right, so we got moles of that, and we're putting moles of Fe on top because that is what we circled. That is what we're solving for. So, just like above, when we had to fill in these other things about waffles, we pulled these numbers from the recipe. This is our recipe right here. We have mole ratios in it. So, if I tell you that the bottom number is going to be a 2, so 2 Fe2O3, what is the top number going to be for Fe? 4. No, it's going to be 4. 4. Look at your balanced equation. All right, so we had a 2 coming from right here. So I put that 2 there. The 4 came from right here. So now we have 12 times 4 over 2. Get that answer, please. Actually, I can show typing it in with the parentheses. It might be helpful to be using these calculators with the parenthesis option. Can't always guarantee it on the phone. So I have 12 times 4 divided by 2. 24. Yep. So we have 24, and then you got to label what that number is. 24 moles of Fe. Okay. Okay, quick question before I keep going. Does this make sense, the times in a line? Instead of doing the railroad tracks, is this good? Like, to kind of help? Like, now you're like that is what we've been doing this whole time. If the railroad tracks made more sense, please go back to it. Do that, okay? That's how I've always done it. But this hopefully opens your eyes to what you're actually doing, and that is 12 times the fraction 4 over 2. And it's all these fractions just being multiplied, okay? All right, go ahead and flip over your page. I would like this page completed before you leave, and you'll turn it into the box today, unless I'm getting you to do other work. But let's look at number 1, just to make sure you understand how to start it. So we have how many moles of H2 are needed to produce 1.25 moles of H2O. So we're going to underline our number with the words attached to it. We're going to circle what the question is asking for. How many moles H2? We're going to set it up 1.25 mole H2O. Okay. Let's say times in a line. And again, this is just all over the number 1, if that makes more sense. Okay. Times, we're going to have moles of H2O down below because we want to cancel that out. And moles of H2 will be on top. This just comes from our balanced equation. So we have 2H2, 2H2O. Okay? All right. If you're doing the railroad tracks before I totally set you free, all that it would have looked like was this. You bring your words down up here. Oh, not the H2O, sorry. Scribble that part out, and you would have had your 2 down here, 2 up here. So if that's making more sense, go back to that. That's fine. All right. But I want times in a line for those of you who maybe weren't understanding this part. Okay. All right. So you have till the end of class. Go ahead and get to work on it, and then we'll kind of go from there. Okay.